Okay. For division, these instructions are going to parallel to a great extent the multiplication instructions. In fact, just the single operand multiplication. Again, I have two division instructions. I have div for unsigned and idiv for signed division. Okay? So, division instructions start with a double length dividend and a single length divisor and produce a single length quotient and a single length remainder. So we're doing long division here, where the sizes of the different pieces becomes very important. So let's look first at unsigned division. For unsigned division, I have the source or divisor may be byte word or double word. Okay. The source can be a register or memory. Cannot be an immediate value. The location of the dividend is always in some form of the accumulator. Okay? And again, we'll go over that. And as I mentioned a little bit earlier, well, back at the very beginning of Chapter 4, in division, because of the nature of the algorithm that is used when we do long division, although the flags will be set every time I subtract the divisor from the dividend, my ending settings in the status bits of E-flags are not predictable. So, if you're ever asked to report what's in E-flags after division, say put question marks or say not applicable. It doesn't apply. I don't know what they'll be. I know that they changed or they had the potential to change, but I don't know. There's no way to predict exactly what they'll be. Okay? All right, so let's talk a little bit more about the source and the dividend. Okay? If the source is byte, the dividend is word, and is assumed to be stored in AX. Okay? So in this case, source is byte, then we're going to do AX divided by source. Okay? And we'll talk a little bit about where the results of this are going to go. If it's word, then the dividend is a double word and will be in DX AX as I divide DX AX by source. D word will be in EDX EAX. Okay? Alright, so let's talk a little bit about what's going on with long division. And let's just kind of define our terms real quick, make sure we're all on the same page. This is the dividend. This is the divisor. This is the quotient. And of course, this is the remainder. Okay? Okay, with unsigned division, it's just that easy. What we haven't talked about, though, is where the quotient and remainder will go. So this kind of gets back to what we were doing just a second ago. So if my divisor is byte, my dividend is in AX, the low order portion of the dividend will become my quotient. The high order portion of my dividend will become the remainder. So in doing a division, I am overriding the dividend every time. It's going to get overwritten by remainder quotient. Okay? If my divisor is word, then my operand or my dividend is in DXAX, so the quotient is going to be AX, remainder in DX, and so on. Okay? So, not too bad. Again, working very similarly to what we would expect. So let's look at an example. In this example, I am dividing, my divisor is word, so my dividend is DXAX. So in DXAX, whoops, in DXAX, I have 100, Okay, so this is 100 divided by my divisor, which is in bx. So this is exactly what we just used, our example we were just using. So this is going to go in 16 times. 16 times 6 is 96 with a remainder of 4. So my remainder is going to go in the high order portion, and my quotient will go in the low order portion. And again, if I'm asked to report anything on flags, put a question mark. With division, we have no idea what it might end up being. Okay? All right, sign division. Unlike sign multiplication, we only have the one format for sign division. And the only difference here is how we handle the rule of signs when I actually do my division. Okay? All right, so let's go ahead and look more into this. One thing I'll point out, though, is, and let's go back. Okay, let's say I've got, let's use our same example, 100 divided by -6. Okay, what is my quotient going to be? Well, it's going to be -16. My remainder is going to be +4. Okay, what if it's -100 divided by +6? In that case, my quotient is going to be -16, but my remainder is going to be -4. This goes back to what you're doing with division. Quotient times divisor plus remainder should give you your dividend. So -6 times -16 is positive. 96 plus 4 is positive 100. 6 times -16 is -96 plus -4 gives me my dividend. Okay? Bottom line, the sign of the remainder, you'll notice in both of these examples, the sign of the quotient is the same. The sign of the remainder will always match the sign of the dividend. Okay? So just in case you can't remember, that's the way we'll do it. All right, let's look at an example. Very similar. In this case, we're going to do I div bx. Bx is word, so my dividend is in dxax. Dxax is our example that we just did. So -100 divided by 6 is going to give me -16 with a remainder of -4. Okay, -4 is what's going to go in dx, and -4 is going to be ff, fc, f. And then my quotient will go in ax. -16 is ff, f0. Okay? All right. This down here, by the way, is just our reminder of where all the pieces go. All right. Well, let's go back through the other version of that same example. In this case, I'm dividing 100 by -6. My quotient should be -16. My remainder will be 4. So, in dx, my remainder is stored as 0004. My quotient is still -16. So ff, f0. Okay? All right. In everything that we've done, with both signed and unsigned division, well, especially signed division, either one, we haven't even looked at how we get the dividend in the appropriate registers. Think about it. We did division by a word-sized divisor that assumed my dividend was already in dxax. I have no idea how to get that in there, okay? Well, we actually have a couple of ways to do this. So, first of all, if I'm dealing with unsigned division, then what I could do is I could move my double-sized dividend must be converted to quad word size with leading 0 bits in EDX. So to do that, I could say move 0 in the EDX, or even a bit more efficient, subtract EDX from itself. Okay, that will clear out EDX. EAX, I'll just have to make sure that's where the dividend is. Gets a little trickier when we have sign division. So the dividend must be sign extended with those extension bits put in EDX, and I've got some instructions that are designed just to do that. The convert to instructions. The first one, convert byte to word, word to double word to quad word to even bigger. Okay? Each of these is going to copy the sign bit of the original to the high order half of the result. So, in this case, I'm going to convert byte. Let's say my byte is going to be AL, and let's say in hex it has F0 in it. When it converts that byte to word, the entire thing is going to go in AX, and it's going to take the sign bit of AL, which if we wrote it in binary, my sign bit would be 1, so it would be all ones or FF, F0. So that sign bit would be extended to the high order portion of the dividend. Same as in convert word to double word, that's going to take AX and sign extend it to DXAX. CDQ is going to take EAX and sign extend that to EDX, EAX. Okay? Alright, so none of these will affect flags because all I'm doing is copying the sign bit, so I'm not going to see any effect. So these are designed specifically for use with the division instructions, but they're kind of handy. And we were talking about how do I sign extend things. I could do it the way we did that example earlier in the chapter, or I can use these special purpose move and extend instructions. I actually have a couple of them. Move ZX is move and 0 extend source to register. Okay, so move with 0 extension. This is going to move an 8-bit or a 16-bit source to a 16-bit or 32-bit destination, 0 extending the source value, so 0 extending. The other version is move and sign extend. Again, destination, source to destination. So this behaves in the same way, so it's going to move the 8-bit or 16-bit source to a 16 or 32-bit designation, sign extending the source value. This gives me a lot more flexibility. I'm not restricted to AX, DXAX, or EDX, EAX. I can sign extend it to anything I want to. So, again, if I need to sign extend, that's what we'll do. All right, we've got a couple of examples that we're going to do, but we're going to do those in class. So, we'll call this the end of Chapter 4.